Today, we turn our gaze upward toward a rare event that only a handful of generations will ever witness. Astronomers have detected a traveler from beyond our solar system, a body not born under the warmth of our sun, but forged in a distant star's nursery and flung across the galaxy until it wandered into our skies. This interstellar visitor has been named 3I 2025 P1 Atlas, or simply 3I Atlas. It is only the third confirmed object of its kind in all of human history. The first, discovered in 2017, was the enigmatic ʻOumuamua, a strange, elongated shard that left more questions than answers. The second, in 2019, was the comet Borisov, which looked far more familiar, with a glowing coma and tail. And now, in 2025, we welcome a third guest, one we have discovered early enough to study carefully as it passes by. At first glance, it was nothing more than a faint dot among countless stars. In early July, automated survey telescopes spotted a tiny speck shifting subtly against the background sky. Most such detections turn out to be ordinary comets or asteroids, the sort we see every week. But this one was different. Its path through the heavens traced not a closed orbit around the sun, but an open, hyperbolic curve. That single mathematical detail revealed its extraordinary nature. This was not a child of our solar system. This was a visitor, a traveler, just passing through, never to return. The discovery was made by the Atlas Survey System in Hawaii, a network of telescopes designed not for beauty but for safety. Atlas spends each night scanning the skies for anything moving fast enough to pose a risk of colliding with Earth. Instead of danger, on that quiet July night, it delivered discovery. A tiny pixel of light, flagged by software, would soon reshape our view of the cosmos. Within hours, astronomers across the world were alerted. Data flowed rapidly from one observatory to another. At first, it was designated with a provisional name, just another comet candidate. But calculations soon confirmed the truth. Its speed was far too great to be bound to the sun's gravity. With that realization came a new designation, 3I 2025 P1 Atlas, marking it as the third interstellar object ever identified. To call something interstellar is to acknowledge its strangeness. It means the body was born under a different star, perhaps billions of years ago, in a planetary system we may never know. It means that its long voyage across the galaxy has carried it untouched through the darkness until, by chance, it wandered close enough for us to see. And it means that when it leaves, it will be gone forever, continuing on a one-way journey through infinite night. The first nights after discovery were tense but exhilarating. Astronomers knew how fragile such detections could be. A faint pixel of light might vanish in the noise or turn out to be an error. But the data kept building frame by frame, night after night. Soon, the truth was undeniable. This was real. Large observatories quickly joined the effort. In Chile, the Gemini South Telescope, perched high in the Andes, collected enough light to sharpen the speck into a clear point. Soon after, faint signs of a surrounding haze appeared. A coma, the glowing cloud of gas and dust released as the object warmed under the sun. Not long after, a slender tail stretched outward, unmistakably pointing away from our star. What began as a faint dot had become a living comet, its identity written in light across the sky. This was the moment when excitement spread beyond astronomers. The comet wasn't just a number in orbital models anymore. It was visible, tangible, alive. a comet from another star system, showing the same behavior as comets we know, yet carrying within it the chemistry of a different world. Compared to its predecessors, Atlas seemed both familiar and unique. ʻOumuamua, the first interstellar visitor, had shown no coma or tail, only an elongated, tumbling shape that defied easy explanation. Some even speculated wildly about artificial origins. Borisov, the second, had been far more recognizable, sporting a bright tail, much like local comets. Atlas, the third, stood somewhere between them, unmistakably comet-like, yet carrying subtle differences in its chemistry and brightness. This raised profound questions. Were interstellar visitors a diverse family, each shaped by different stars? Was ʻOumuamua an exotic shard of rock, while Borisov and Atlas represented icy wanderers? Or were these just the first hints of a much wider variety of interstellar debris? Whatever the answer, each new discovery added depth to the puzzle, showing that the galaxy is filled with far more than stars. It is also filled with travelers cast adrift. Confirmation came not only from Earth. The Hubble Space Telescope, orbiting high above our atmosphere, turned its steady gaze toward Atlas. Free of atmospheric distortion, Hubble's sharp eyes captured the delicate structure of its coma and tail in exquisite detail. Soon after, even the James Webb Space Telescope joined in. Its infrared instruments detected the faint signatures of gases streaming from the comet's surface, revealing not just what it looked like, but what it was made of. For scientists, the most thrilling moment came when Webb's data showed chemical fingerprints that did not quite match local comets. There was water vapor, yes, but also an unusually high abundance of carbon dioxide. The ratios were different, pointing to conditions in Atlas's home system that were unlike those in our own. For the first time, humanity was holding not just an image of an interstellar object, but a glimpse of its true alien chemistry. This is why such discoveries matter. A comet is more than a speck of ice and dust. It is a frozen archive, preserving the conditions of the place where it formed. To study one from another star system is to open a package delivered across billions of years and light years, a cosmic letter from a place we cannot visit. Astronomers circled an important date on their calendars, October 30th, 2025. On that day, Atlas would reach its perihelion, its closest approach to the Sun. At that moment, its ices would erupt into their most vigorous activity, and the comet would shine at its brightest. This would be the best chance to study its chemistry, its dust, and its behavior before it faded back into the dark. The countdown had begun. By late summer, Atlas had become more than a faint curiosity. Its coma grew larger, stretching tens of thousands of kilometers across, while its tail lengthened into space like a luminous banner. To the naked eye, under city skies, it remained invisible. But to telescopes, both professional and amateur, it was unmistakable. One of the most curious features of comets is their tails. Most people imagine them streaming neatly behind the nucleus, like exhaust from a rocket. But in reality, a comet's tail is shaped not by its motion, but by the sun. Solar radiation and the solar wind push gas and dust outward, always away from the sun. This means a comet's tail can sometimes point sideways or even ahead of its path, depending on the geometry. For Atlas, this tail became a vivid compass needle, tracing the invisible flow of energy through space. The comet's chemistry played a crucial role in this display. As sunlight struck its surface, frozen gases began to sublimate directly into vapor. Water ice, carbon dioxide, and even traces of carbon monoxide streamed outward, dragging dust particles along with them. These dust grains reflected sunlight, creating the golden glow of the dust tail, while gases fluoresced in green and blue hues depending on their composition. Through telescopes, observers noted a faint green tint, the telltale glow of carbon-based molecules energized by the sun. Astronomers compared Atlas to Borisov, the interstellar comet of 2019. Both showed classic cometary behavior, with comets and tails. But there was a crucial difference: time. Borisov had passed through the inner solar system quickly, giving scientists only a brief window to observe. Atlas, by contrast, had been detected early enough to allow months of preparation. Instruments could be scheduled, data pipelines refined, and collaborations organized. This made Atlas not only a rare discovery, but the ideal interstellar comet for study. As October approached, anticipation grew. At perihelion, the comet would come closest to the Sun, though still at a safe distance. There was no danger to Earth. Its orbit carried it millions of kilometers away from our planet. Yet in astronomical terms, this was a close encounter. For weeks, around this date, telescopes across the globe would focus on Atlas, capturing every detail of its activity. To astronomers, perihelion is like opening night at a grand performance. It is the moment when a comet reveals its full character. For Atlas, the stakes were even higher. This was our only chance to see it in its prime. Once it passed perihelion, it would begin to fade, growing dimmer each night until it slipped beyond the reach of even our best instruments. The speed of the comet added urgency. Atlas was racing through space at tens of kilometers per second, far faster than most solar system comets. Gravity bent its path, but could not capture it. This velocity was itself a signature of its interstellar origin. Only something flung free of its birth star, wandering across the Milky Way for millions or billions of years, could carry such momentum. For amateur skywatchers, Atlas became a challenge and a thrill with modest telescopes under dark skies. Its faint glow could be captured in long-exposure photographs. Online communities buzzed with images, delicate tails stretching across star fields, subtle Comet captured against the Milky Way. Each photograph represented not just personal skill, but participation in a cosmic event that would not repeat. There was poetry in this too. To watch the tail of Atlas was to see sunlight sculpting matter from another star system. Each dust grain carried in that plume was once part of a distant planetary nursery, perhaps billions of years old. Now it drifted in our sky, a visible trace of a history written far away. For scientists, the true treasure of Atlas was not just its beauty, but its chemistry. Every comet is like a frozen time capsule, a remnant of the conditions that existed when its parent star was young. By analyzing the gases and dust that streamed into its coma, astronomers could read its story as if it were a letter written across light years. The James Webb Space Telescope proved invaluable. Its infrared eyes split the comet's faint glow into a spectrum, revealing clear signatures of water vapor, carbon dioxide, and carbon monoxide. These were familiar substances, but in unfamiliar proportions. Compared to most comets born around our Sun, Atlas carried an unusually high abundance of carbon dioxide. That detail mattered. It suggested Atlas had formed in a region of its original star system colder and richer in carbon-based ices than anything in our solar neighborhood. Its birthplace may have been far from its parent star, in a zone where even volatile ices could freeze solid. By carrying this chemistry intact for billions of years, Atlas delivered direct evidence of another world's nursery conditions. The ratio of carbon dioxide to water became one of Atlas's most distinctive fingerprints. Local comets usually fall within a predictable range. Atlas stood apart. This was proof that the recipe for building planets and comets is not universal. Each star system mixes its ingredients differently, and Atlas was carrying a recipe we had never seen before. Dust added another layer to the story. As sunlight pushed fine grains into the coma and tail, astronomers measured how the light scattered. Some particles were as small as smoke. Others were as large as grains of sand. Their colors and reflectivity revealed minerals and carbon compounds, unlike typical solar system dust. Each grain was a fragment of a world we will never see, released into space and carried across the galaxy until it fell briefly under our gaze. What astonished many researchers was how quickly the data converged. Observatories from Chile, Hawaii, Spain, and South Africa shared results almost in real time. Students, amateurs, and professionals all contributed. Within weeks, Atlas's chemical fingerprint had become one of the best documented interstellar signatures ever recorded. It was not just one telescope's finding, but a global consensus, a portrait painted collectively for the wider world. The meaning of this was profound. This was the closest humanity had ever come to sampling another planetary system directly. We cannot yet send spacecraft to other stars, but Atlas brought us a piece of one. Its gases, dust, and ice carried the physics and chemistry of a place beyond imagination, preserved for billions of years, now unveiled in our skies. But the significance of comets goes beyond science. For most of human history, they were omens, messengers of change. In ancient China, they were recorded as warnings tied to dynasties. In Europe, they were seen as swords of fire or divine signs. Even today, there is something haunting about their sudden appearance. A brightness that doesn't belong. A light that drifts and then vanishes. Atlas fit into that long tradition. It arrived unannounced, glowing faintly against the star fields, carrying not only data for astronomers, but wonder for anyone willing to look up. For some, it was a scientific object. For others, it was a symbol, a reminder that we are not isolated, that the galaxy sends us visitors, and that sometimes the universe allows us to see them clearly. Where did Atlas come from? The truth is, we may never know for certain. Its exact birthplace is lost to history, its orbit bent and nudged by countless stellar encounters during a journey that could have lasted billions of years. But astronomers can piece together a likely story. Atlas was probably born in the outer regions of a young star's planetary disk. In the early days of any solar system, giant planets stir the small, icy bodies around them, scattering them inward and outward. Some become comets that loop back endlessly. Others are ejected entirely, flung into interstellar space with a single violent push. Atlas was almost certainly one of those outcasts, a small fragment exiled from its home system before it ever had the chance to orbit steadily. Once free, it began a journey through the interstellar void. For billions of years, it drifted in darkness, its ices preserved by the cold of space. Stars were born, lived, and died, while it wandered untouched. Galaxies collided, nebulae bloomed, yet Atlas remained, a survivor of deep time. Occasionally, It may have passed near other stars, each encounter bending its course ever so slightly. These gentle nudges eventually brought it into the neighborhood of the sun. By sheer chance, after eons of silence, it crossed paths with a species capable of noticing it. Some astronomers suspect Atlas may belong to the thick disk of the Milky Way, a population of stars older and poorer in heavy elements than the Sun. If so, Atlas could be older than Earth itself. Imagine that, a fragment of rock and ice, born long before our world existed, preserved perfectly until now. To study it is to hold a fossil of the galaxy's earliest history. This endurance is part of what makes Atlas so valuable. Few objects in the cosmos survive unaltered for billions of years. Planets evolve, stars erupt, collisions destroy. But Atlas persisted. It is not only a messenger from another star, but also a survivor of cosmic time, carrying the record of conditions that existed before our solar system formed. The mystery of its true home may never be solved. Too many encounters, too many random deflections have erased its trail. Yet that anonymity gives it a universal quality. Atlas does not belong to one star. In a sense, it belongs to the Milky Way itself. It reminds us that our galaxy is a web of connections, stars, planets, and fragments all interacting, scattering, and sharing material across unimaginable distances. When we look at Atlas, we are not just seeing a comet. We are seeing the movement of matter itself, drifting endlessly from one system to another. It is migration on a cosmic scale, written into the fabric of the galaxy. As autumn of 2025 approached, anticipation grew. Astronomers had marked a single day on their calendars, October 30th, the date when Atlas would reach perihelion, its closest point to the Sun. For comets, perihelion is the moment of truth. Sunlight pours energy into their frozen surfaces, awakening hidden ices and releasing spectacular jets of gas and dust. The coma swells, the tail stretches farther, and the comet shines at its brightest. For Atlas, this was the one chance to reveal its true character before fading away. All over the world, observatories coordinated their schedules. From Hawaii to Chile, from Spain to South Africa, telescopes prepared to capture every spectrum, every image. Space-based instruments like Hubble and Webb were aimed carefully to catch the show without interference from Earth's atmosphere. Even spacecraft orbiting Mars were readied as the comet's geometry all owed for a unique view from the red planet's neighborhood. This was more than science. It was a global choreography, a relay of observations passed from one hemisphere to another as the Earth rotated. Data flowed in almost instantly, shared among teams, and posted in public databases. What once would have taken months now took hours. In real time, humanity was collectively watching an interstellar traveler bare its soul. At perihelion, Atlas did not disappoint. Its coma expanded into a shimmering halo, tens of thousands of kilometers across. Its tail unfurled like a banner, swept by the solar wind into a luminous arc. Spectra confirmed violent outgassing, water vapor, carbon dioxide, carbon monoxide, and dust erupting together in a temporary storm. Cameras captured faint shades of green and blue, glowing within the haze, the fingerprints of alien chemistry excited by sunlight. For professionals, it was data. For amateurs, it was wonder. Photographs appeared online, each one showing the faint blur transformed into something unmistakably alive. People with modest backyard telescopes shared the same cosmic visitor as the world's largest observatories. Atlas had become not only a scientific object, but a shared human experience. Yet everyone knew the spectacle would not last. Comets are ephemeral. The same sunlight that awakens them also consumes them, eroding their surfaces and scattering their material into space. After perihelion, Atlas began to fade. Its glow diminished night by night, its tail thinning, its coma shrinking. The storm was passing. There was melancholy in this fading, but also gratitude. The comet had given more than anyone expected. Months of visibility, rich chemistry, a clear tail, and a story written in spectra and images. Where ʻOumuamua had baffled and Borisov had teased, Atlas had delivered clarity. It had shown that interstellar comets can be dyed deeply, that they carry secrets of alien worlds, and that when chance offers us a gift, humanity is ready to receive it. By the time Atlas slipped beyond the reach of telescopes, its legacy was secure. Data had been archived in countless observatories. Papers would be written for years to come. Students who had cut their teeth analyzing its spectra would remember it as their first brush with the infinite, and skywatchers, who caught its faint glow through their lenses, would remember the night they captured light from another star system. As Atlas drifted away from the sun, it grew fainter with each passing week. The bright coma thinned into a pale haze. The once proud tail stretched weaker and dimmer until it blended back into the star fields. For astronomers, the data stream slowed. For skywatchers, the comet disappeared into memory, but its fading was never the end. It was simply the closing of a window. The comet had carried its message, revealed its chemistry, and left its trace in the archives of science. From now on, Atlas would continue its journey outward, unbound, slipping once more into the vast emptiness between stars. Humanity had been given only a brief audience. The traveler itself remained indifferent, silent, timeless. What Atlas revealed was more than numbers. Its orbit told us it came from beyond. Its chemistry told us that other systems are not like ours. Its endurance told us that fragments can survive billions of years in the cold night of the galaxy. Each piece of information was a gift, a glimpse into the diversity of worlds we will never visit. Yet its legacy is also emotional. Comets have always been symbols, as well as objects, harbingers, mysteries, lights that arrive without warning and vanish without explanation. Atlas, though grounded in modern science, stirred the same ancient awe. To see its faint glow was to connect with humanity's oldest instinct, to look upward, to wonder, to search for meaning in the sky. Perhaps that is the greatest lesson of Atlas. Not only that our solar system is not isolated, but that the universe is constantly in motion, scattering fragments, sharing materials, exchanging pieces of itself across unimaginable distances. Planets form and die, stars flare and fade, and in the quiet between them, travelers like Atlas drift, carrying their stories until someone is there to listen. When future generations look back, the year 2025 will be remembered as the time we welcomed our third interstellar visitor. By then, there may be more. New telescopes will be scanning. New missions may even fly out to greet them. But Atlas will always hold its place. The comet that came not too fast to study, not too faint to ignore, but just right for us to truly learn. Now, as we close the story, picture the comet far beyond our reach, its light swallowed again by distance. It will never return. Its course bends outward forever, carrying it back into the galaxy, where it will wander for ages upon ages. Perhaps it will pass near another star one day, long after our own sun is gone. Perhaps somewhere else, another civilization will watch it briefly and wonder as we do now. For us, Atlas was a reminder. The universe is vast, but it is not empty. Across the distances, across the centuries, sometimes the stars send us visitors. And when they do, if we are watching carefully, we may glimpse not only another world, but also our own place in the cosmic story. And so we say farewell to the comet Atlas, a stranger from the stars, a fleeting companion, a messenger of time and distance. Its visit is over, but its meaning endures.